Alright. So, welcome to the long-awaited Chapter 4 tutorial for Gaddis C++. Today you're going to be learning how to code the failure that is Yandere Dev, where he utilizes the one thing, if statements. This is mostly going to be centered around if statements. We finally made it. We can make a whole game out of this. Alright, that's enough of the joke. Seriously though. So let's get on with it. Okay, so like in math, okay, when you want to compare two things to two numbers, anyways, two values, we got these operators: greater than, less than, greater than or equal to, less than or equal to, equal to, and not equal to. Now, something I'd like you to realize here is that we put two equal signs when we want to check if something is equal to something else. Because one equal sign means you're just declaring it as, you're declaring it as a value. So if I put, let's say I got a variable x, and I want to say that it's equal to something else. Like I want to check if it's equal to something else. Like, let's say, does x equal y? I do two equal signs. If I want to say x is equal to y, like I'm not comparing, I'm saying that's an order, that's what you're going to put it as, then you put one equal sign. Everything else is self-explanatory. Then not equal to is like you want to check it doesn't equal to that, greater than, less than, you'll see. Here's the appropriate examples. If you don't want to read that. So right here we got an example program where we're checking. You can do a comparison and get the true, check if it's true or false, and store the fact that it's true or false as a bool value. So true is 1, false is 0, and right here we got the variable true value equals x less than y, is x less than y. If it's true, it's going to be 1. If it's false, it's going to be 0. It's going to equal 0. And we got a false value, a variable false value equals does y equal to x. So there's this thing that I've been seeing in a lot of these textbooks that try to do these real life applications. I don't mean programming textbooks, by the way. I'm talking about these math textbooks or these science textbooks or whatever that they're teaching to, middle schoolers and high schoolers, that they're trying to give this illusion that they are learning something that's a bit global. Even though it's about geometry. I don't know why. Like it's geometry or something. I remember in my geometry textbook they were talking about if statements, and just to somehow bring a real life example. I don't remember the context, but they were implying that you would actually be writing you'd be writing if, and you'd actually literally be writing then. And that's not the case. The then is implied, and you're going to see how these if statements are written. But that's a small detail I like to address. Some programmers, I'm sure I've seen, not programmers, but students, when they were writing their programs, are like, okay, when do we put the then? They were actually asking that in my class. It was kind of funny. So the next thing I'd like to address is that you don't check one condition at a time for your if statements. You check multiple conditions. What I mean by that is that You wanna you don't do. Let's say there's three things you're looking for your favorite burger. Yeah, let's do that. Everyone likes burgers. Okay. So let's say this one guy wants a cheeseburger with ketchup on it, and he doesn't want any pickles. So that he wouldn't do if there's cheese, if there's no pickles, and if there's ketchup separately. He wouldn't write those out separately. Then he would buy the burger. He would do if there's no ketchup. If there's ketchup, no pickles, and there's cheese on it, then I'll buy the burger. Like, he says that in one sentence. He doesn't do three sentences separately. Likewise, you would be doing the same with in C++. You'd be checking for whatever it is you're checking as one statement. At least as much as possible. Sometimes you obviously need to, depending on the context, you actually need to split it up. But the other thing is that whatever statements are going to be going on, you wouldn't be putting a semicolon on a if statement. Anything that needs, any commands that need to be concluded are concluded within the if statement itself. You'll see what I'm talking about. So right here, we're not using brackets because this guy put an if statement that's only one line long, and in this case it's okay to you not have any brackets to contain it. But in that place where it put if A equals B, you wouldn't do if A equals B semicolon and then write your C out. Both A and B are the same. You just you write it like that. The example is 100% correct. This segment would work. So that thing about, let me escape so I can hover my mouse. So right here, these are what I mean by brackets. When you have multiple statements multiple commands that you want to do in your if statement, you have to put this bracket. You can't go over here and you do an indentation, put it below the if statement. Even if it was just one command, out of habit, I don't like doing this. It's good for the sake of readability to add these braces. So, yeah. Alright. Now, as we saw here, we have not just ifs, but we also got elses. And I don't know why the example they put for just if, they put the else and decided to later have its own if-else section, but whatever, that's fine. So if something doesn't go right, the else, I guess you could say, would be the closest thing to literally saying then. Like the not case. If this is not the case, then that's what you do. And that's all there is to say about it. If statements can be nested, you can put multiple inside of each other. And when you're gonna do the problems in the textbook, assuming you're not cheating, you're just looking up the solutions, you'll see why you need to do this. But this example is kind of cringe anyways, because if you wanted to check both if employed and recent grad, like, are you employed and are you a recent grad, you wouldn't need two separate if statements. Like, this is what you do. You would do if employed and recent grad, you qualify for the special interest rate. Okay, I don't need to waste time writing that. Like, you don't need that. Alright, the reason if-else statements exist, and we get the else-if statements, I should say, is when you're trying to check for multiple things, and you got what you wanted, then you're going to stop checking for the rest of those conditions. So, let's say there's, you're looking for one particular trait, and you're going to deal with that one particular trait. And if you got that trait, then you stop thinking about the rest of the things that might concern you. Then you'd stop at the part where it's if. So in this example, we have expression 1, expression 2, and up to expression n, and finally we have the else. So in the case that expression 1 is satisfied, we stop checking everything else. We don't go to the later else ifs. This is something I should have considered when I wrote down the solutions, but they're still valid. You feel free to optimize them and take up less resources. This is important because you do not want to waste precious computer time checking those other conditions if you've already got what you're looking for. You don't, imagine you have 26 backup plans or something, right? And you're trying to do, you've got a main plan in mind, but you've got 26 backup plans. If the first plan worked, you don't do the other 26 backup plans. You just go with the first plan. You don't need to think about those other 26. But if the first one doesn't work, then you go on to the second one, or the third, or the fourth. Let's say you finally manage to get stuff working with the 5th backup plan. You don't do the other 21. Which is why you make use of else if. That's you save a lot of time. You save a lot of the computer's time by not making it think about doing those 21 other plans. That's why you use else if. If the requirements are met in the first place, are already met, then stop thinking. Otherwise, keep checking until we hit else, which the else probably is maybe it will give you an error, like it'll tell you that you've messed up, there's something wrong here, or whatever the programmer has in mind. Maybe it's just a default value. Like he'll say, okay, you passed all certifications, congratulations. The many ifs and else ifs were just trials to see if you qualify, if the values qualify for something. So when I was talking about you could put multiple conditions, these are the tools you would use. You've got these 3 operators: and, or, and not. And or not. This saves a bit of writing, to say the least. Here is an example of when you'd be using and here's an example. So I had written this, the if employed and recent grad. That's its usefulness. You don't need to do a nested if statement right there. Or, so right here we've got if the income is greater than or equal to the minimum income requirement, or you've got enough years under your belt, as in you've got more years than the minimum required amount of years, then you'll qualify for the loan. So you only need one of those. You don't need both of those for you to qualify. It's only when you fail both of those that you can't qualify for the loan. False is false. If you don't So, before, if either of these values were true, it would put you like this guy was checking for true values to say you qualify, and he just switched it around to demonstrate the false operator. The operator to say something is false. Whereas, if you don't have the minimum income or the years, then it would show this, and the else is the one with only one line. One line here, one line here. Checking numeric ranges. So, those operators like the greater than or less than, greater in this case greater than or equal to, less than or equal to, this is when you don't want to write and several billion times to account for all the numbers you had in mind. You just say, is it greater than or equal to 20 and less than or equal to 20? That means he's thinking about ranges between 20 and 40. Then X is in the acceptable range. Okay, I think in this previous chapter 3, where we was talking about ASCII values and stuff, it turns out you don't actually need to look up the ASCII value if you want to compare it. You can just compare the characters themselves, which is kind of funny. You don't even need that table. So they had this program where it checks if something is a digit, an uppercase letter, or a lowercase letter. He doesn't even put the ASCII values. He just puts the characters themselves, and it works. This program actually works. The same values for the ASCII values for the characters, they carry over to strings. You can compare strings, you can compare characters. And in this case, Mary is a greater value than Mark, because even though MAR is the same, the Y is a higher number than K. So that's why Mary is greater. Not because it's, not because the compiler is sexist or anything like that. It's just because it's looking up the value of each letter and comparing those two, value by value. The total value anyways. You should read conditional operators. I haven't used them that much. Oh, and here's switch statements. Let me see, where's their program? Yeah. So, look at this explanation, because I've heard some people get mad about depending on how you describe a switch statement. So I'm not even gonna I'm not gonna put it into my own words. It's better for you to just read the textbook, then think, okay, if we want to get philosophical about this or more technical, then I should look at someone who understands it even better than the author of this textbook. You shouldn't be asking me. How it looks and how it works, though, is very similar to how it looks. Just how it looks is very similar to if statements. So you have one set of braces thinking about several cases in mind, and which is like, so case 1, case 2 is like, if this, and this would be like the else, kind of. Yeah, look through the book's examples for these. Scope. If you put, you declare a variable inside an if statement. Let's say, for if he declared income within the if statement over here, that it wouldn't, this variable wouldn't, the income value wouldn't exist beyond the if statement. So if you call it outside the if statement, say, oh, I'm going to add 2 to this variable, it wouldn't work. That's what that's about. That's that section about it. Section 15 goes into depth about it. And we are done. If this episode seemed a bit low quality, too bad, because the main point of these series is just to make it easier for you guys to find the solutions to the problems anyways. If you enjoyed it, however, that's great. Hopefully you learned something. If you didn't, well, better luck with the book, man. I tried. A little bit, at least.